So exam 1 review part 1, the derivative of the following functions. So a function is x times natural logarithm of x cubed. So we can just call them y equals to the function x ln of x. And this is 3 copies of ln of x. And the derivative here, we apply product rule. So that means to get y prime, we have to find derivative of x, that is x prime, multiplied by ln of x cubed plus x, then the derivative of ln of x cubed, but now it's derivative prime. That's a product rule. Let's start. We have derivative of x, it's 1, so we only have ln of x cubed plus x. The derivative of ln of x cubed, we will employ chain rule by setting ln of x to be u. So in simple terms, we're finding derivative of u cubed. And this is a polynomial. So you find the derivative by dropping the power, subtracting 1 from the power, we get u squared. Then you multiply by the derivative of u. So this one becomes natural log of x cubed plus x multiplied by 3. U, it's natural log of x, but now squared. Then you multiply by derivative of u, the derivative of natural log of x, that is 1 over x. So you divide all this part by x. So the result becomes natural log of x cubed plus 3 natural log of x squared. That's the answer to number 1. Or you can write it in this form, natural log of x cubed plus 3 natural log of x squared. Second one, we say y equals to natural log of x to the power of 9 base 4. And we convert this one into index notation. So we have 4 to the power of y equals to x to the power of 9. And because you want to have y on one side, we can introduce natural log. So we have y natural log of 4 equals to, can have natural log of x to the power of 9. Not natural log of 9 to the x power 9, but natural log of x to the power of 9. It's x to the power of 9. So to be left with y on one side, we have y equals to natural log of x, and this we're having 9 copies of x divided by natural log of 4, which is a constant. So the derivative y prime should be equals to, a constant is 1 over natural log of 4, and then you multiply by the derivative of natural log of x to the power of 9. And the derivative of natural log of x power 9, as we said in class, should be derivative of the function inside the natural log, that is 9x to the power of 8. Then you divide by x to the power of 9. So resulting to 1 over natural log of 4 multiplied by 9 over x. So combining, we have 9 divided by x natural log of 4. For the third one, we can decide as the others, that's y equals to 3x squared plus 10. This can be written as exponential natural log of 3, because that's still 3. Then x squared plus 10. And the good thing with an exponential function when finding the derivative, the y prime we can move this one. So y prime will be equals to the function the way it is exponential natural log of 3 x squared plus 10. Then you multiply by the derivative of the power part. And the derivative of this is a natural log of 3, that's a constant. The derivative of x squared power, you can find the derivative of x squared plus 10, that's just 2x. So rearranging this, we have 2x natural log of 3 exponential natural log of 3, then x squared plus 10, which can become constants first, 2 natural log of 3, x, exponential ln, that will automatically become a 3, so that becomes 3, x squared plus 10. So I can have this constant in the parentheses, like that. Finally, for this section, it's the number 4, y equals to x to the power of sine x. We can decide to use logarithmic differentiation, or we can use the exponential again. So let me use logarithmic differentiation. So use logarithmic differentiation. Meaning, I'll have introduce natural log on both sides. Natural log of y equals to natural log of x to the power of sine x. So this will become natural log of y equals to sine x, natural log of x. And then you apply implicit differentiation on the left-hand side. So with respect to x, they apply implicit differentiation, natural log of y equals to, on the other side, derivative with respect to x. Then this side, the product of two functions, sine x multiplied by natural log of x. So derivative of natural log of y with respect to x, it's 1 over y, but you attach y prime. So you have 1 over y times y prime equals to derivative of this side is the product rule. So I'll call this part u of x and this v of x. And let's start by the derivative here. You becomes u prime v plus v prime u. So derivative of sine, it's cosine, then attach ln of x. So it's cosine of x, ln of x, plus derivative of ln of x is 1 over x. Then you attach sine x. Then after that, because you wanted y prime or dy dx, so y prime will be equals to, you multiply by y across, so you have y cosine of x, ln of x, plus 1 times sine, it's sine of x, divided by x. And then y was the original function, so y prime equals to x to the power of sine x. Then in the parentheses, you have cosine of x, natural log of x, I can put parentheses on x's, plus sine of x and then I'm dividing by x. That's the end of part 1.